recording, just so we have a record. And I don't forget. Last time in geology class, I totally forgot to start recording.
Yeah.
Okay, so who thought the homework was difficult?
It was torture.
Torture?
I didn't even
Alright,
do it. I missed
I wouldn't
the
go as
class.
far as torture.
Oh, you missed the class. Okay. Who thought it was easy? Couple people?
Literally one hand is raised.
Or medium in between?
Yeah, I'm kind of like in between.
Levi thought it was
between?
fun to go deep into the fractions. He was like, I'm going down a rabbit hole.
You
All
can't.
right, so
do fractions.
I will say that it's good that it's hard. Okay, it needs to be difficult. It needs to be hard. This is the time that you're learning how to overcome really difficult things, right? So later on, when you see them, you'll be like, oh, that's a breeze.
My advice is don't say it's easy because she'll just give you harder work.
Actually, yeah, that's probably true. But there's a reason, because if it was easy, would everyone do it?
Yeah.
Yeah.
Yeah, you're doing things at your age that kids your age are not doing. And the reason is because it's hard. But the good news is when you persevere and you do hard things that take a long time and it's super difficult, how do you feel when you actually overcome it and you solved the problem and it took forever and you're like, oh my gosh, I got it. How did you feel?
Great.
Who's Jen?
Really proud of yourself, right?
Who's Jen?
That's Miss Jen. Hi, Miss Jen. So you should be really, really proud that you tried really hard and you worked through problems. And I'm going to go ahead and say this now. They're, 11th grade problems. These are very difficult. This is something that you'd see in a math competition or a college entrance exam. It's very, very high level things, but you've proven to yourself that you can learn it. It might take a long time, but you worked through it and you got it. So you guys should feel really proud. All right, speaking of that, let's go over some of the practice problems. We can each person can screen share, or I can do the whiteboard again and you can write it on there. How do you guys want to do it?
I can do the whiteboard. I can do the whiteboard. I know how to do the
For
whiteboard.
everybody to screen share, you'd have to allow us to all screen share.
Yeah, that's true. Okay, let me see if I can do this real quick. The only reason why I say that is sometimes it's difficult to write on my sharing thing.
Does it
We'll try it on mine first since we'll already be on there. If my internet lets me, hold on. Okay. It's being slow again today.
finicky?
Yes, finicky. Again, if I randomly just pause and get offline, continue whatever your chat was. All right, can you guys see that?
Yes. Yeah.
All right, cool. Awesome. Let me see if I can see you guys for some reason. It moved locations. Okay. All right. Who wants to do the first problem? Any takers? And just remember, this is all nope. Oh, okay.
Nobody wants to do it. It's me.
Yeah, go for it, Lola. We're learning together. It's okay if we get it right and wrong.
Oh my gosh, stop. People are like making it green.
Yeah,
Okay.
don't make it green. All right, what do we got?
The first problem is 9. Wow, that is way too big.
That's okay.
It's
Probably
9
okay.
to the 3/2. I don't really know how to say it.
Yep, love it.
So the first thing that you'd want to do, you'd want to take the 3. You want to put the 9 in parentheses with a 1/2.
That's
And
right.
outside the parentheses, put a 3.
Very good. Break that apart because we like the half number because the half represents what?
The half represents
Like
1.
like
Oh.
the exponent half, sorry.
Yeah.
The exponent half represents square root, right?
Mhm.
And we know that, right?
So next thing you'd want to do, because once you get a 1 over a number, you can turn it into the square root. So then
That's
it
right.
becomes the square root of 9,
Yep.
which is wow, I'm going off the page. Which is 3. So
Uh-huh.
then it just becomes 3 in parentheses, exponent 3. And then all you have to do, you multiply numbers that are outside of parentheses to the numbers that are inside the parentheses. So then it becomes the exponent of 3, which is 3 to the third, and that's 27.
Very good. Good job. 3 times 3 times 3, 27. All right. Excellent job. Who wants to do number 2? Come on.
I don't have my homework, so I don't know.
Oh, okay. You want me to write it down for you? Here, so I'll write down number 2. Let's see if I have it in front of the page. Oop, that's from last time. All right, number 2's problem was 3. So the cube root, is that how we say that?
Mhm.
All right. Hopefully it can. There's always a lag on my end. Sorry, guys. Okay, there you go. Who wants to do that one? Emma, you want to try it? So we don't like that radical sign there. Well, let's get that off.
Okay. You would do
Does anyone know what to do next?
The next thing that you want to do, you want to turn that into
it would be 81 and a half.
and 1/2. Yeah.
Not a
Do you like
half,
my-
right? Because that's the cube root.
Do you like my rainbow picture frame?
All right, are we paying attention? All right, so we wouldn't say it's a square root, it's a cube root. So it wouldn't be a half, it'd be what?
It'd be at 1/3.
3.
Right, that symbol right there just means to the third. Right, so that's all we're gonna do is we're just gonna transfer that 81 and we're gonna just put the third, right?
Yep.
All right, now what do we do, guys? Does anybody know what happens with an exponent to an exponent? What you do?
An exponent to an exponent, you just multiply the
You
fraction.
multiply.
That's right, you multiply. So we can cross reduce that, like, okay, so here's the knowledge of our fractions, right? If you multiply 1/3 times 3/2, you can reduce it to what, guys?
To a half.
Yeah. Reduce to 1/2. Okay, so that's easy. Now you just have what?
81 and a half.
And
Which
what does
is-
that mean?
9.
Yeah, the square root of 81, which is 9. All right, let's do the next one. All right, who wants to do this one? Somebody else.
Me.
Okay, who's me? Levi?
Yeah.
Yes, that's me.
Okay, me, let's go.
All right. This is number 3, right?
Number tres, yes.
All right.
Do you want me to write it or can you write on the thing?
I can
would
write.
try.
Except
You would try.
whoever's writing there, you might want to clear what you have written.
I can speak
Oh,
German.
that's me. Hold on, I'll clear it like this. New page. Might take a second. There you go.
So it was what 60 4 to the -4/3.
Aha. Okay.
This writing is terrible. All
That's
right.
fine.
Well, that could be the same as 64. 64 put that in parentheses to
Okay.
the 1/3
Okay.
and to the -4th out here.
Okay, cool. Love it. So what
And
does
then
the 1/3 mean?
that means that you can turn it into a cube root
That's right.
of 64.
That's right.
There's that's the -4th. And
Awesome.
that equals, that's just 4 to the -4th.
Right.
And that equals, since it's a negative, you can turn it into a fraction.
That's
So
right. Yep.
1/4 to the 4th, and that is just 1/256.
Very good. Excellent job, Levi. So we're learning there more negative signs and what you need to take when you have a negative exponent, and that's the reciprocal of that number. And you did a great job. Excellent. All right, number 4. Any takers?
I'm waiting
Looks
until we
like
get to the big ones.
we
Lower.
have
Me.
Okay, Lola, go for it.
Yeah.
We're doing a 5th root.
Okay, let me write it.
Oh, I remember you going through this one, Lola.
So, oh, what? My thing's not on. That doesn't make any sense.
Look at all those zeros. All right, what do we got?
The first thing that you want to do, you want to take it out of being a root.
The radical
and-
sign, yeah?
Yeah, the
Mhm.
radical sign. And instead, what you want to do, you want to put the 100,000 into parentheses,
Okay,
and with the exponent to the exponent of 3 inside the parentheses, and then outside the parentheses, you want to put it 1/5 or whatever kind of root that is, and then you want to flip it as putting the 1/5 inside of the parentheses and the third outside of the parentheses.
okay, yeah. All right,
And
Perfect.
then you can
so what
turn
is the 5th root of 100,000? So what does that mean? The 5th root of something?
you just it times by itself, by itself, by itself, by itself, by itself.
5
And
times,
it
that's
gets
right.
Yeah.
So what number does that?
10.
10, there you go. All right. Now there's our scientific notation, isn't it, guys? What do you do with the 3? Or 10 cubed?
That's 1,000.
That's right.
3 zeros.
10 times 10 times 10. Is that what you got, Lola?
Yep.
Good job, Lola. Excellent.
Hey, Miss Tara,
Yeah.
I actually did this one differently, much differently than she did.
Okay. Why don't you show us? What'd you do?
So, so let's start with the problem that's like what 5 to the 100,000.
Uh-huh.
A lot of zeros. I went ahead and changed that to 5 to the 10 to the 5th.
Okay.
Oh, and there's also a third over here. So don't
That's
forget
right.
third. So if you multiply those, then it'd be 5 to the 10 to the 15th.
Mm-hmm.
And then you could change the square root into a fraction. So it'd be 10 to the 15th
Okay,
to the 1/5.
love it. Okay,
And if you multiply those two exponents, then it'll make just 10 to the 3rd.
that's right. 15
And
over
that
5.
equals,
Yeah.
that equals 1,000.
I love it. Perfect. I thought you were going to say right in your square root, your 5th root, sorry, not square root. I thought you were going to say in your first step, the 5th root with 10 to the 5. I thought you were going to go, those two cancel out and make 10.
Oh, that
But
would be
I
so
love
much
your-
easier.
Yeah, because the 5th root of something with 10 to the 5th is the opposite. I love it. I love the thinking. So this is all about, because I mean, how easy is this? If you have a scientific calculator, you could literally put this into the calculator, right? So this is all about manipulating the numbers and understanding how it all works. And this is great. I love it, Levi. Way to think outside the
Thank
box.
you. Yeah.
All right, let's see, number 5. So 2 left. This is a fraction. I can write it if anybody wants to.
Oh, that fraction.
Can I do it unless nobody else wants to do it?
I'll try to do it.
Okay, go for it, Em.
4
So
to the 9.
I would say in this one, there's a rule, right? So if you have something in parentheses, so you'll learn if you've done algebra before, right? So if you have 4 times 9 and you have a fraction or some sort of exponent on the outside, what would you
You
do to that?
multiply it.
Well, what would you do? You would distribute each of the
Oh,
terms.
sorry, yeah, distribute.
Yeah, so this line right here is just division. So you would do the exact same thing. So what would we get?
We would get 4. oh. We would get 4 to
what?
the -3rd.
-3/2. I mean, you're just distributing it, right?
Yes.
And then what do we do with that?
And then it's 9 to the -3/2.
Right. Okay. And then where do we go from there? Because I don't really like that fraction there in the exponent.
We
I like things that are square root and cube root. How do we get it that way? 1 over something. Mom, yeah, you can have it. Mom. Yes, buddy.
We would subtract it because division means subtraction
Right.
of the
So-
exponents.
So Lola, what comes next? What would you turn the 4 in 3/2 into?
You would turn the 4 on. Oh, okay. I thought you were saying 3/2. You would put the 4 and then have the exponent of -3/2.
Right. And then what comes next?
You'd on just the 4 on 4 and 9.
You'd flip it.
Well, you'd
So-
have to.
Oh
you
no,
have to
you'd
do
put it
this.
into you'd put it into like a 1/2.
Yeah, we
Okay.
like the square root of things, right?
Yeah.
Okay, and we do that for the
For
bottom
the
as well.
same thing.
Okay, so we'd go the square root of 9 to the -3. Because we know what those square roots are, right, guys? What's the square root of 4?
The square
2.
root, 2.
2. And what's the square root of 9?
3.
Okay, so then all we have is our lovely little negative exponents there to deal with.
We flip them, so it
Yeah.
becomes a non-negative.
Okay, so we're gonna flip the top and the bottom, so they switch places, right?
Mm-hmm. 3 over
Okay.
2.
3 to the third over 2 to the third. All right, so what's our answer?
We have 27 over 8.
There we go. All right, last problem, guys. You're doing good. All right, fourth root, 1/16 to the negative third.
I do know
Who
Levi
wants to
wanted
do
to
this
do that
one?
one, so.
All right, let's get a newcomer. Who hasn't done a problem yet? Let's do a problem.
You're gonna give him like the hardest problem?
Levi, you
Yep.
wanted to do it.
Oh, Levi, you want to do the hardest one?
Yeah, I like the hardest problem.
Okay, go for it.
But if someone else wants to do it, they can do it.
Any other takers? I don't see anyone jumping up and doing to do the hard. You're the only one who wants to be tortured.
Hooray.
All right,
Alright.
challenged, we should say.
Yeah, challenge,
what-
challenge.
Okay.
So we have the fourth root of 1/16 to the negative third. I started with turning that into 2 different fractions. Like
Okay.
I turned it into it's a lot of parentheses. 1/16. That was more
Mhm.
like a 3 in the 16th, but 1/16 to the 1/4,
Okay, yes,
and then all that to the negative third.
very good. Yeah.
And then that's just and then I made even more fractions. So I decided to do 1 to the 1/4 over
Okay.
1/16 to the 1/4.
Okay, so you distributed your exponent. I love it.
Yep, and then all that to the negative third again. I'm just gonna keep that negative
Okay.
third. And then that changes because 1 times anything is just 1. So it ends up as 1 over 1/16 to 1/4,
To the third. Yeah.
and then to the negative third.
Yep. Perfect.
And then since there's just that 1/4, since there's just a 1/4 back now, I can go back to kind of like to original problem,
Uh-huh.
except for instead of the negative third being on the inside. Oh, that was the 4's in the wrong area. I'm just gonna so instead of having the 3 on the inside, the 3 is now on the outside. So it'll be easier to turn that into it's easier to solve that now.
Okay.
And that would just be, and then I could turn that into just 1/2 because that's the square root of, that's the 4th root of 1/16. That's the negative third. And then I'll turn that into another fraction. Hooray, fractions, we all love them. 1 to the negative third over 12. Oh, I'm sorry, 2. It's supposed to be 2, not 12.
I was about to say you're writing 12, but I think you mean 2. Okay.
Over 2 to the negative third.
Okay.
And again, since 1 times anything is just 1, it's 1 over 2 to the negative third, which is 1 over, wait a minute. Yeah, 1 over 2 to the negative third, which is just 1 over 8. Well, actually 1 over 1
Wow.
over 8.
Over 8. Very good. Yep.
1 over 1 over 8. And we can simplify and we could simplify that down to 8 over 1.
Yep.
So it
Well,
would be just, yeah.
Very
And
good.
then
It's
it'd just be 8. Hooray, 8.
very
8.
good. Good
Yeah,
job,
bro, that
Levi.
equation, the whole equation just equals 8.
Great job.
So
But
let's see if I can,
Miss Tara, I have a question.
yeah.
In what situation would you have that equation? In what real life situation would
You
you
have
need
to know
use
how to
that?
open the toilet.
Yo, what? You need 8 ounces. You need 8 pressure ounces
8 ounces of
force,
toilet water.
8 ounces of toilet water.
Don't you want to be a
20
rocket
seconds in the
scientist?
bathroom.
Miss
If you
Tara,
want to be a rocket scientist, you'll have to do that. Yeah.
I just got here. Could you go over the answers again for 1, 2, 3, 4, and 5?
Sure.
Grace,
let
I
me
can
go
go
I want
over
to check
with
my
you.
answer.
I can
Yeah,
help you with
you
them
can check
later if you want.
All right, so 1 is going to be 27. 2
Got
is
that
going to
one.
be 2 is going to be 9.
Mhm.
3 is 1 over 256.
Okay.
4 is 1,000.
Mhm.
5 is 27 over 8.
And 6 is 8, so I got all that. I got them
Good
all right.
job. All right, let me
Yay.
rewrite it. Does anybody want me to write this? Does anyone want me to rewrite what Levi wrote? Or is anyone copying it down or anything?
Oh, I've already written it down. I can just.
Okay,
Just copying it down.
okay,
That's how I did it.
okay. Okay, so you solve for inside first. Yeah, see, this is what I was saying. You can actually put this into, if you have a scientific calculator, you could put a 4th root of something together. Like if you don't want to do it step by step. You can do it that way as well. I would say, go on.
I changed I changed the fraction and flipped the 16th and the 1 to
Yep.
make it 16 to
Yep.
make the exponent positive.
Yep. Okay, so that's a great point. So Grace saw the -3 there and went, I'm going to go ahead and flip this, right? I'm going to go ahead and make this 16 to the 3rd, right? So this looks better. And
Miss
when she
Tara?
did that, then she took the 4th root of that number. Yeah. Okay, so now I have a question. All right, so let's move on just a little bit more. All right. Okay, so what is this, guys? What's the answer to that? The square root of 25.
5.
5.
Is it 5? Is it just 5? Is that literally the only number?
No.
What's another number?
-20. -5.
Yeah. So this is actually how you're going to write this number.
And there's
Plus,
a parentheses
I-
right here.
say that again.
And
Oh,
there's a
I don't know.
parentheses.
I don't know whose parentheses those are. I'll have to, can somebody remove your parentheses?
Miss Tara,
Yes.
I'm gonna do Kahoot.
No, not today. All right, so can you remove I don't know who wrote the parentheses, but. All right, so you have 25, the square root of, thank you. The square root of 25 is going to be plus minus 5. Okay, so here's where our rules of multiplication negative numbers come in, right? If we have 2 negative numbers and we multiply them together, what does it equal?
Positive.
A positive number.
Positive.
Yeah. So when we say the square root of 25, we can actually say it could be -5 as the answer. Okay. So we actually have to put in there positive -5, and that's how you write that. Okay. So the same thing with, a good example would be 9, right? What's the square root of 9?
3. Plus or
Is it
minus
3?
3.
It's a positive -3, right? Because -3 could also be that. So this is a good scenario when you start getting into algebra. This is why you do it. You'd have x squared equals 9, okay? How would you actually solve this? So the opposite of a exponent is what?
A regular number.
What, a root?
Oh,
Right.
sorry, root. You said an exponent. And like
Yeah,
not a
The opposite of
specific
exponent would be root.
so-
Like if we wanted to get rid of this 2 over 1, we'd have to multiply this exponent by 1 over 2,
Yeah,
right?
but what we do to one side goes to the other side.
That's right. So we'd have to do 1 over 2 to the other side. And that's just the square root of 9. So x
is 3.
could equal, right,
Plus or
but
minus 3.
when we start doing geometry, it's either +3 or -3.
Plus or minus 3.
Yeah. So that's going to be important. Okay, so let's try to do some examples. Let's see. We're going to say that x equals -2 to the 5th. Now this is going to, we're just going over rules of multiplying negative numbers, right? Because the exponent of something is just multiplying that number that many times. So if you have an even exponent, what is the answer going to be? Is it going to be negative or positive?
Positive.
Yeah, positive.
Okay, if you have an odd exponent, what is the answer going to be?
Negative.
It's gonna be
Negative.
Right, because -2 times -2 is a positive, right? Times another negative is a negative, times another negative becomes a positive again.
Positive.
And then times another negative is back to a negative again. So if you have an odd number exponent with a negative number here, you're multiplying, the answer is going to be what?
Positive.
No, an odd number
It's
exponent.
negative.
Okay, so what is 2 to the 5th or -2 to the 5th? Anybody got a calculator? 2?
32.
I have a calculator.
32. Okay, thank you.
Oh,
So is
sorry.
it positive 32 or
My
is it
dad's good at
negative?
math.
Is it negative 32?
It's going
We
to
have
be
this.
a positive 2.
Well, we got an odd number exponent.
Oh, then negative.
Yeah. Okay, so let's keep trying this positive and negative exponent thing. All right. Let's see, we're gonna do, or sorry, not positive and negative exponent, positive and negative base number. I'm speaking wrong. All right, so let's say x is going to equal your cubed root of a -8. Uh-huh. So what do we want to do, guys? So we learned from last class, what's a cube root of 8? What's the number of that? We memorized that one.
2.
2.
Yeah. So a cube root of an 8 is what? 1 over 2. Does everyone see that?
Yes.
Yeah.
Okay. Okay, so except that we had a negative number, we multiplied it 3 times. So that's an odd number. So what's our answer going to be, negative or positive?
that is going to be negative.
It's gonna be a negative half for x. Okay, this is gonna be important when you start graphing, okay? All right, let's continue. Let's do, all right, if it's x to the 6th power equals 64. Who wants to do that one? Super easy.
Oh, wait,
So
I
how do
have
we
a
get rid of
calculator for this.
x to the 6th? How do we get rid of x to the 6th on one side?
Erase it.
So this.
2.
Great. Let's make it 1. How do we make this 1? How do we, if we want to solve for x, we got to get rid of this to the power of 6. So you have to do the opposite, right? So this is 6 means 6 over 1. So we have to multiply it by 1 over 6, which is just the 6th root of something, right?
Yep.
Okay. So let's do what you do to one side of the equal sign, you have to do to the other. So we're going to also take the 6th root of 64. Does anyone want to put that into their calculator, or do you just know it? Does anyone know
I
the
just know it.
What would it be?
2.
2. All right. Is it just 2?
Positive or negative 2.
That's right. Positive or negative 2. Negative 2 can also be an answer. All right, let's keep going with some more algebraic expressions here. All right, x cubed also equals 64. All right, so what do we do now, guys? So x cubed also equals 64. What do we do to the cubed? How do we get this off to this side? Anybody? Hey, guys.
I like numbers.
So what's the opposite of cubed?
Cubed root.
Not cubed.
Cubed
Um,
root.
He
Okay, if you want to get rid of something, the
cube would be-
opposite would be the cube root. So what's the cube root of 64?
4.
A cube
Very
root.
good.
Oh, it's 4.
Good job. Yep. All right, let's keep going. What if x equals, we're going to do a negative base number here. And something you guys are familiar with is,
Mhm.
hey, can somebody erase the 4 real quick, or I can get
Oh,
a new piece
yeah,
of
that's mine. Sorry.
paper. Okay. Okay, so what's this? We have a negative 27 to the negative 2 over 3. So what do we want to do with the negative 2 over 3?
Make the 27 into a fraction.
Okay,
1 over 3 to the negative cubed, squared.
okay. Do we know the cube root of 27? Or negative
3.
27? I should say. Yep. But is it just 3?
Nope.
Negative 3. The cubed root of negative 27 is negative 3 to the negative 2. All right, Levi, you love fractions. What do we have this negative sign up here? What does that mean?
Well, negative signs mean that you have to, that means if it's a that means it's gonna be a positive answer because the negative exponent, and there's two. It's an even exponent.
It's true, but what do we have to do to this base first? Don't we have to make it into a fraction?
Yes, yes, we do. Because we all love
Yeah.
fractions.
We love fractions. So let's get that negative sign out of here and let's go ahead and flip this, right? Let's make it look a little better. All right, so now we have that negative exponent sign out of the way. So let's just solve, right? So what is -3 squared?
You asking me?
1.5.
1 over what?
9.
9. And of course it's positive, right? Like Levi said, because you're multiplying it twice. And two negatives multiplied together equal positive.
Positive.
That's right. All right, let's do another one. Let's say x to the 5/3 equals 243.
What was the answer to the last one?
1 over 9.
I got it right.
Good job. All right, well, this is our last one. It's the hardest problem.
Oh no.
Who wants to do it? All right, so this is just learning methodology. All right, Lola, you were really good at these exponents here.
Oh, Lola's gone. She went to the bathroom.
Oh, okay. Who else wants to do it? Let's see. Somebody new. So we have 5 over 3. How do we get rid of 5? How do we get rid of 5 over 3 as an exponent? Miles, do you know? What would we have to multiply that to equal 1?
I have no idea.
How about 3 over 5? What if I multiplied that 3 over 5? Wouldn't those cross cancel out? Can we cancel out the 3's and the 5 and that would equal 1? So you see that if
Yes.
you want to get rid of an exponent on one side, you take the root of it, which is just that exponent flipped. Okay, so what we do to one side, we're going to do to the other side. So we multiplied this side by 3 over 5, and we're going to do the same, or sorry, we took the exponent of that by 3 over 5. We're going to do the same to the other side. Okay, so now we have 243, 3 over 5. I do not like the way that looks. What do I need to do?
Need
sense.
to split it or put it into pieces.
Sure, let's
You
split
break
that
it into
fraction
little
up.
tiny pieces.
So we have 243, and what does it turn into? What's my exponent now?
Your exponent is now 1 over 5.
To the
I
third.
think. To
Yes.
the third, yes.
That's correct. What is the 5th root of 243? Come on, Grace, you got this. or anybody with a scientific calculator that could put in the 5th root of 243.
3.
I have a calculator on my phone. Does that work?
Sure.
All right, I'll try and do that.
I don't
All
think
right.
that's the right answer.
3.
3. And we put our third back on there. What is 3 to the third, everybody?
3 to the third is 27.
1, 2,
27.
7.
I had
Good
it at the bottom.
My sister
Is
does
that what you
too.
got, Grace? Oh, look at you. She says negative or positive 27.
Bum, bum,
Let's-
bum.
Well, it's an odd number. So it would be just positive. Yeah. Okay.
I got 27.
Yeah, you got it right. All right, now I have a harder question for you guys. And Levi kind of like touched on this a little bit last class.
I thought you said the one we just did was the last one.
Well, I want to kind of introduce something for next time.
Okay.
How about what's the square root of 8? How do we do that?
There is no square root of 8.
There is an answer.
I did that on my calculator.
Yeah. I'm about to say your calculator will give you an answer. That's right. Okay, so what do we do here? So all this is
Wait, like to the third or to the second?
okay, so the square root of 8, when you have something like this that's not a perfect square, we try to always simplify it the best we can. So we try to pull out perfect squares. Okay, so what two numbers multiplied together would equal 8?
4 and 2.
4 and 2.
Four.
So Grace, by the way, Grace, you got it right. So 4 and 2, right? Okay, so do you see a perfect square in one of those numbers?
4.
4. What's the square root of 4?
2.
2.
2. So we can pull that out. Okay, so that's 2. And then all you have underneath the radical sign is a 2. That's how you solve that problem. Is that easy, hard? Do we get it? We want to do it again.
That's interesting.
I get it.
Okay, now it gets harder when we have bigger numbers. This is where using prime factoring comes into place, but we'll kind of go over that a little more next time. Let's see, 96, we'll do one of these. 96, all right, square root of 96. We need to pull out perfect squares, all right? If we don't know, well, then we have to find prime factors of 96. Like what numbers multiplied together would equal 96? So you guys just call out what two numbers multiplied together would be 96.
12 and 8.
Okay,
43 times 2.
okay, well, we're gonna go with 12 and 8 because that was the first one that was, but there's yes, you're right. There's multiple numbers that would do this. All right, so now we're going to factor this. What two numbers multiplied together would be 12? So that'd be what? 2 and 6.
2 and 6.
Okay. And then for 6, that'd be 2 and 3. All right.
Mhm.
And then we're going to factor 8. So I don't know if you guys remember factorization. But
4.
that's what we're doing.
4 and 2.
All right. 4 and 2. And then with 4, 2 and 2. So we got them all down to our prime numbers. How many 2s do we have?
5.
We have 2 to the 5th. Yep. And how many 3s?
We have
One.
1, 3.
Okay. So square root of 96, another way to write it is the square root of 2 to the 5th times 3. Okay. And that's how you work that problem. And we know how to take the square root of each of these numbers. Okay. And this is going to be super, super, super important. I'm going to show you a very easy way and a very hard way. All right. So if we have this, we don't like this radical sign. This radical sign also equals 1/2. And that's what we're going to do. We're going to go say 2 to the 5th times 3 parentheses 1/2. Okay. What do we do when we have two terms inside of parentheses with an exponent on the outside?
You multiply them.
Well, we have to distribute first, right? Okay.
Oh,
So we're going to
yeah.
distribute our exponent to each of the terms. Okay. So we get left with 2 So the 5/2 times 3 to the half. All right, now this is the most confusing part, if you can believe it, out of this whole thing, but it's absolutely crucial for you guys to get. Okay, when you see this exponent 5/2, what do we call this in fraction terms? We call this an improper fraction. You guys remember improper fractions?
Oh, I
Yeah.
know that.
Yeah,
Yep.
that's when the numerator is bigger than the denominator, right? All right, so we do not want improper fractions as our exponents. So how many, so we're actually going to turn this improper fraction into a proper fraction. Does everyone remember how to do that? How many, basically, you're just saying how many 2s are in 5, right? So how many 2s are in 5?
2.
Two.
2 2s are in 5, right? So
2.5.
this turns into, there are 2 2s in 5. And how many is left over?
1.
1. So this is how you would write that problem. You'd say 2 squared times 2 to the half. So you'd split up that improper fraction and make it a proper fraction, 2 to the half. Okay, and you'd still have your 3 to the half. All right, now I see a perfect square in here. Do you guys see a perfect square?
I see a perfect square.
I mean, it's staring us in the face. There's literally a square right there, right?
Mm,
So
Yeah,
what
I
is
see that
2
square.
squared? So what's 2 squared?
4.
1.
2 squared is 4.
4.
So we have 4.
What?
And then we have the leftover stuff is 2, the square root of 2 times the square root of 3. All of this can be put under the square root. The answer would be 4 square root 6. All right, now I'm going to show you guys the super simple way. Y'all ready?
That wasn't the super simple way.
Oh, no. No. All right. At the beginning, you want to, if you have a square root of 96, you want to choose numbers that multiply together that would be perfect squares. So numbers to choose that multiply to 96 are things like 16 and 6. Okay. Now, is one of those numbers a perfect square? Like, what's the
Yes.
square root of 16?
4.
Okay, so you can go ahead and pull that out. 4, and what's left underneath the radical sign? The number what?
6.
And we're done.
Ah.
That was interesting.
Yeah, so there's multiple ways to do it. You can even do it when you're factoring, okay? So if you start factoring 96 and you start seeing perfect squares, you can start pulling them out underneath the radical sign, okay? So if you see a 4, like which we did, right? We can start pulling that out. Okay, so that's different ways you can do these problems. And I'm going to give you guys some cool example ones. Oh, you know what? Let me do a real easy one just like that. Y'all ready? All right. The square root of 1440. Does anybody see a perfect square you can multiply this number by? What 2 numbers would you could multiply this by? So the hint is this
Back to the
0.
calculator.
Well, no, the hint is this 0, right?
Oh, 10.
10. So 10 times what is 1,440?
144.
144 times 10. Is
Grace
that,
already got the answer.
yeah, is 144 a perfect square?
Yes.
What times what is 144?
Oh, 12 times 12.
12. So let's go ahead and pull that out. We have 12 square root 10. And your answer's done.
Wow.
Now, there's a hard way to do this. If you don't want to put 144 and 10, okay? You can prime factor this out to your heart's content. Take that radical sign off, make it a half, and break it all the way down to this exact same number. Okay?
Good simple way.
This is the simple way. That's right.
Yeah,
So
feel
this
better
is
doing this.
That's right. So this is a really good example of how it's good to know your perfect squares, your multiplication numbers, and you can start pulling those out underneath the radical sign, right? Any questions? Because we're at our time limit here.
I do Kahoot.
I don't have a Kahoot for math. I might actually do a Kahoot for math like at the end of this session.
Semester.
Like, it doesn't it'd have to be way easier to solve, yeah. But I'll give you guys a couple more examples for homework. You know what I'll do this time? So I'll probably give you 6 problems is good, but I'll give 6 problems and only work the ones that you're comfortable with. So the people that feel comfortable just doing the easy ones, that's fine. And then the ones that just feel it's all easy, you do the hard ones, right? That way we have a mixture of questions for everybody. All right, anybody else have a question while we do this? You guys did great on the homework last time, by the way.
Is there gonna be more
Yay.
homework?
I
Yeah.
wasn't here last time, so I don't know like any of this. I was just trying to go off of what you guys said and trying to work things out.
Well, I've recorded the first one. So if you want to go
Alright.
back and have your mom show you the first one, it explains the basics of exponents and square roots.
Alright, yeah, you could do that.
That'd
Thank
probably
you.
help a ton.
Thank you.
All right, anybody else? I'm gonna post some. Do you want me to go ahead and tell you guys you can write down the problems? Or do you want me to post them online?
If you post them online,
Yeah, I can do that. So your mom can print them out?
yeah.
Okay. But it's gonna be the same basics. It's gonna be a square root of a number and a nth root of a number. Now, next time when we're done with this, it gets even wackier, guys.
Uh-oh.
Because we're actually going to start to talk about imaginary numbers. You guys ever worked with the little I before in math?
Oh, isn't that like
No.
beyond infinity or something?
Yeah, it's an imaginary number.
What about infinity?
I for imagination.
I mean, can't
Yeah.
infinity be like different types of infinity? I guess one infinity can be longer than one infinity.
So it's not necessarily an infinite number.
Bro, little I to the second is bigger than little I. How does that even happen?
It usually
little
has
I?
to do with numbers that are negative. So we'll talk about that next time. And then we'll eventually get to logarithms, and you guys are going to love those because it's going to make your life a lot simpler. And there's definite applications for that all the time.
What would happen if you put infinity as an exponent?
If you put well, I don't know what you do for infinity. I don't know. Put it in your calculator. I don't think they have infinity as a button.
I don't think so either.
His calculator is pretty advanced, so it might.
Wow, this thing does have an I and an infinity.
Oh, good.
Yeah, it's like
Well,
practically a second phone because you can put like
So-
a phone number into it.
See what you can figure out, Levi, and report back to us.
All right.
But we will be working with some pretty cool numbers next time. All right, any other questions before we stop our recording here? And I'll probably just end the record.
Oh.
Any questions before I stop recording? Speak
So
now.
I equals I. It just tells me that I equals I.
I.
Yeah, his
equals
doesn't give him
I.
any fractions.
But I to the second is -1.
Stop share. All right, let's see. No questions. All right, this is supposed to be difficult. Remember, we like difficult things because we're doing things that no other person is doing your age, right?
You like easy.
It was funny because I was looking up some of the standardized tests here in Newfoundland and in Texas. And some of the problems that we're doing are on tests, but they're high school. So it's pretty cool. And the one for Newfoundland doesn't even do, I mean, you had to go through all the way to 12th grade in order to get this stuff. It's pretty cool. So you guys should be very, very proud of yourself. This is all about building your personal confidence to see very difficult problems, working really hard and feeling proud about yourself that you actually did that. So the fact that you're learning and you're already doing things and trying to learn things that kids your age are not learning. I can probably guarantee you that any of your grade tests would not have this on there.
Really?
Oh yeah. Well, that's not why we learn, right? Like even my science class, a lot of the stuff that we learn in science class is never going to be on your grade level tests. That's not the point, right? The point is not to teach to a test. The point is to see how far you can take your brain. Push it to the limits. Because trust me, when you guys get to college, it's going to be just like this. There's going to be multi-ages in your college class, right? There's going to be people that have taken the course before. There's going to be older people, right? There might be a younger person. And all different age groups are learning the same thing. And this is some of the things that you'll learn. And when you take a test, sometimes they grade what they call on a curve. And that just means your competition is going to be the person sitting next to you for grades, right? So if everybody fails a test, let's say, and the highest grade was a 27 out of 100, which has happened before, then that person gets the A, and then everyone else below that person is kind of divvied out the next grades, right? And that's called grading on a curve. And that happens very often in science classes that are very, very difficult. So the fact that you're learning with multi-level people, some people get it and some people don't. And what you need to learn is I was one of those people in science class that all these other people got it. And I had to stay in the library and study 2 more hours than everybody else just to understand it. But with that came, I felt really good once I got it, right? And that seems to be life, because when you get a job, I guarantee you there are going to be a lot of people that know more things than you. So you got to study really, really hard. But you guys are doing awesome. This is very difficult. Well, who thinks it's easy? Let's put it that way. Some people might actually think this is easy.
Emma thought the homework problems are
I'm
easy.
better at like biology and just other things. But math is my weakness in school.
Well, that's perfect. If math is your weakness, you're in a great place, because it's overcoming those really difficult things. And the great thing about this class is there's no tests, there's no quizzes. You should have no anxiety over this. It's if you get something wrong, everybody's in the same position, right? So it's okay. This is a great place to learn. And Grace thinks it's easy.
Some of it is
Apparently.
easy. Some of it.
Well, you're gonna do the hard problems next time. But that's awesome. I think every one of you guys is doing great. And some of you might have to work a little harder than others, but you should be really, really proud of yourself you're doing this. Is there any questions about today or tomorrow or coming up?
What are we doing tomorrow?
Oh, sorry, not tomorrow.
Next
week.
time. I was about to say,
Unless you want to
you didn't tell me
Not
anything
every
about
day.
tomorrow.
All right, let's see.